Hello everyone, this is the course on engineering graphics and we are discussing on the module of projection of solids. This is the third lecture in the series on projection of solids. In this session we are going to discuss about projection of solids with axis inclined directly or indirectly to both the reference planes, that is to both HP and VP. This is also called as the case of oblique solids. Oblique in the sense inclined axis to both reference planes HP and VP. So it is a case of oblique solids. Let us understand the concept by solving some examples. Let us see this example. A hexagonal pyramid, edge of base 30 mm and axis height 100 mm is lying on one of its triangular faces on the ground, and the edge of the base contained by that face is inclined to VP by 45 degree. Draw its projections considering apex nearer to VP. So first thing is that this solid is a hexagonal pyramid. Second thing is that it is lying on one of its triangular faces on the ground. So in this case, when anything is lying on the ground or HP, we take the first step and the axis of the solid perpendicular to HP in that step. We are going to break this sum into three steps. First step is taking the axis perpendicular to that reference plane to which or on which it is resting, or any of the part of the base or the slant edge or the rectangular face or the triangular face is on HP. So we will take it on HP. If anything is on the VP, we will take the axis perpendicular to the VP in the first step. That is how we proceed. We are breaking it down into three steps. Okay, so that is the first step. Then the edge of the base contained by that face is inclined to VP by 45 degree. Now that face which is on HP, the edge of the base is inclined at 45 degrees to VP. This data we utilize for the third step. First step is that axis taken perpendicular to HP, we will draw the views. Second step, we will tilt it so that the triangular face rests on HP, that is the second step. And third step, we will turn it in such a way that the base edge is making 45 degrees with VP. So just imagine these three steps. First step, we will take axis perpendicular to HP and we will keep it on HP. This is the step 1. And then in the second step, we are going to tilt it. We are going to tilt it. We are going to tilt it such that the triangular face, it is seen as the edge here. So that triangular face that is here, this one which is resting on HP. So we are going to tilt it so that the triangular face will lie on HP. This is the second step. And in the third step, we will turn it around and the edge of the base, the edge of this base, that is this edge, makes an angle of 45 with VP. That is, we utilize that for the third step. So we will tilt it. We are going to tilt it such that this is making 45 with VP. VP is here. on this side. So this is making 45 with VP, and we will see it here. So this is what is visible. We will draw that in the solution. So step by step we will proceed to solve the sum. First two steps we have solved in the previous two sessions. The third step we will see the construction and drawing of the third step here. So just see the first two steps solution. So this is the first step. We are keeping the pyramid on HP, that is axis is perpendicular to HP. This is the first step. So top view is this hexagon and the triangles for the slant edges. These are the slant surfaces, and front view we are having this triangle apex is seen here in the front view. So this is step 1 solution. In step 2 we are going to tilt so that this face, that is this triangular face here, this will lie on HP. So when we tilt it, keeping this DE on HP, so this DO will bring in line with HP. Okay, and it means that it is resting on this triangular surface on HP now, and we take the projections down, and we take the projections, horizontal projections here, and we will complete this top view in the second step. So we have solved up to this in the previous two sessions. The wordings were different because they were phrased such that the solution would be achieved, and now we have changed the wording a little bit more, so that now the axis is also inclined to VP. What is happening here in this case? First case, axis is perpendicular to HP, parallel to VP. Okay, then we will tilt it. So this is second stage. Second step, what is happening? The axis is inclined to HP and still it is parallel to VP. Okay, so this is the second step. Then the third step, when we turn this around so that this edge is inclined at 45 degrees to this XY line, then what we get is the final shape. That will be the axis will be also inclined. The axis will also be inclined to VP. So let us solve it on AutoCAD and understand the solution there. Now these two steps are solved here. We are going to construct the third step now. Now in this case, third step, we will tilt this top view from the second step such that DE is inclined at 45 degrees to XY. So let us draw the line at 45 degrees to XY projection layer. Then for that you need to switch off ortho and turn polar snap. 45 degree angle should be selected. That range is selected, and let us draw that line here. Say first we will draw a horizontal line. And now we will draw the inclined line at 45 degrees. So this is that line. See, you have two options. Either you draw 45 like this, that is this way 45, or you can draw this way. Okay, this way also it is agreed. So whichever is convenient, you can draw any of the positions, and both of the solutions are correct for this definition. All right. So I will adopt this way and show you the solution. So this is the line at 45 degrees to xy. I have drawn another line here which is parallel to xy, and this is the line at 45 degrees to this line, that is 45 degrees to xy. Now we are going to reorient this top view so that DE is aligned with this 45 degree. Okay, and apex is nearer to the VP or nearer to the observer. What is given, just you have to check that. See, apex is nearer to the VP, it is given, so we have to tilt it such that this O is nearer to the XY line. Okay, so let us do that. For that purpose, we have to select this, we'll copy it first and then rotate. This is copied. Copied, and we have placed it here at this location. Now let us rotate this so that DE is aligned with this 45 degree line. I will select as a rectangle only. See, you should keep off the ortho mode if it is on. Now in this case it is not on, so it is the right thing. So this way it is rotated now so that DE is making 45 degree with XY, or the base edge containing the triangular face is making an angle of 45 degrees with VP. So that is the definition. We have placed it accordingly, and now we will continue for the front view. For the front view, we have to take the projections from this view and get the projections from the second step front view. Okay, and then intersection points we will name them. So we have got these projectors, and we have named the points accordingly. Now let us connect them. So layer, object layer. Now we are seeing it from this side. So what is visible? This base is nearer to the observer, so complete base is visible. So we join those edges with object lines. Lines, I have not selected lines. So these base edges have been connected with object line, and then what is further nearer from this side? FO. So FO, done. Next, you can see AO and EO. AO and EO. Done. Okay. Now what is clearly visible? Can you see DO? No, because it is resting on HP on that. So that is actually behind EO and it is overlapped. So that is done. Next thing, can you see other edges, that is CO and BO? No, CO is far away and similarly BO is also not nearer. You are seeing it from this side, so both will be hidden. So just connect them using hidden line. CO and BO. So those two edges we have connected using hidden line. And what about the axis? Yes, axis is not getting overlapped. So let us draw the axis also. So center layer. Done. So we have completed the front view for the last step as well. So that is how the solution is there. In 3 steps we have solved this sum. So this is the solution. You note down that here apex, this is apex is nearer to the VP. So this apex is nearer to the VP. So that is the thing given and we have followed that. Now another sum we will see wherein the apex is nearer to the observer. Rest of the things are same. Just read this sum now. A hexagonal pyramid, edge of base 30 mm and axis height 100 mm is lying on one of its triangular faces on the ground, and the edge of the base contained by that face is inclined to VP by 45 degrees. So this is almost same. Both the problems are similar here in the wording, except the last sentence, draw its projection considering the apex nearer to the observer. That is the only difference here compared to the previous sum. So it would be solved like the previous sum, except the third step orientation. We will keep the apex nearer to the observer in the third step top view, and then accordingly draw the front view for the third step. Let us see the solution here. So first step, axis is taken perpendicular to HP and the pyramid is resting on HP on its base. Second step, we are going to tilt it. We are going to tilt this so that this will rest on HP. So the triangular face will rest on HP. This is the second step. And in the third step, we will reorient it so that the base edge will make an angle of 45 degrees with VP, and apex is nearer to the observer. That is the difference here. In the previous sum, apex was nearer to the VP, so we have placed it like that. Now for this, apex is nearer to the observer, so we have kept it in this way, so that apex is nearer to the observer, and then we will draw the corresponding front view for the third step. So let us see the solution. The first step solution, that is the pyramid resting on its base on HP with the axis perpendicular to HP. And then second step, Second step, this is the solution that we are going to tilt it, and it will lie on the ground. So the triangular face will rest on HP. This is the second step, and the top view for the second step. And now third step, we are going to reorient. This base edge and draw it at 45 degrees to VP, that is 45 degrees to XY line, and that is drawn now, 45 degrees to XY line, and keeping the apex nearer to the observer. So observer is on this side, that's the reason why the apex is nearer to the observer. The previous sum, the apex was nearer to VP, VP is here, so apex was drawn nearer to the VP in the previous case, whereas in this case apex is placed nearer to the observer. Okay, that is the only difference. Once you draw this in this way, that is, reorientation is done, then we take the projections for getting the front view. So these are the projections, these are the projectors from the second step front view. Intersection points are connected now. The intersection points are named first, and accordingly the connections are done. See, consideration while connecting the points. The observer is here. Whatever is nearer to the observer, that will be connected by object lines. You can see that most of the slant edges, they are seen by the observer. So most of the slant edges, which are the slant edges which can be visible to the observer: FO, CO, AO, BO. So here FO, then FO is done, then BO, so BO, then AO, so here AO, and EO, because observer is here, so EO is also visible, so EO is done. And what is not seen is this CO, because observer is here, this is the far away slant edge, so CO only is connected with a dotted line. And the base edges, FA, AB, BC, so FA, AB, BC is far away. Okay, FA, AB, BC is tilted that way, and so that is not visible. We are seeing from this side, BC is not visible. So what is visible is FA, AB, so that is connected, FA, AB, and then here FE and ED, so FE and ED, so these are all object lines. The remaining two base edges are not seen, so DE, this is not DE is visible, so that is shown here. What is not visible is DC and BC, so DC and BC, they are connected with hidden line. So that's how the front view is also complete. We can draw the axis as well, because that is visible, it is not getting overlapped by any other line, so axis is also shown. Now let us see this sum. A pentagonal prism, edge of base 40 mm and axis height 100 mm, has one of its corners in the HP with the axis inclined at 30 degrees to HP, and top view of the axis inclined at 30 degrees to the VP. Draw the projections. Now what is the case? The solid is the pentagonal prism. Okay, the corner is in the HP, so this is important. So in the first step, we will take the solid resting on HP with the axis perpendicular to HP. All right, then axis inclined at 30 degrees to HP, this is the data for second step. So then in the second step we will tilt it so that the axis makes an angle of 30 degrees with HP, and top view of the axis inclined at 30 degrees to the VP. This is the data for the third step, wherein we will reorient the top view of the second step such that the top view of the axis makes 30 degree to the VP, and then take the projections from the second step front view and complete the front view in the third step. So this is how we have broken this down into 3 consecutive steps. Let us see those models for these steps. Step 1, the pentagonal prism is kept on its base on HP such that one of its corner on the right side of the observer. That is necessary because we will tilt it around this corner, okay, and then that will be helpful for solving it in the second step. So this is the second step. We are going to tilt it in the second step. Now this is what is done. In the second step we have tilted this so that the axis is making 30 degrees with HP. And third step, we are going to reorient this such that the top view of the axis makes an angle of 30 degree with VP. So that will take care in the third step solution. Let us let us see the first 2 steps and then solve the third step on AutoCAD. First 2 steps we have already solved in the previous 2 sessions. Similar sums we have solved. This is the solution for the first step. The pentagonal prism is resting on HP with its axis perpendicular to HP. Alright. Then second step we are going to tilt it. So we have tilted it keeping D dash on HP, and we have tilted this D4 in such a way that the axis is making 30 degrees with HP, and then we have taken the projections. We have taken the projections from the first step. Top view, we have connected the points. We have seen it from this side to connect the points, and the second step top view is completed. Now third step we will reorient this so that the top view of the axis is here. This point to this point is the top view length of the axis. We will tilt it such that this makes an angle of 30 degrees with VP. That means this axis is tilted at 30 degrees to XY line, and reorienting this top view and then taking the projections and getting the third step front view. So let us do that on AutoCAD. So these are the 2 steps. We already solved these 2 steps. Now third step we are going to solve it here. In the third step what is required is that axis top view. Now what is that axis top view? Just see here carefully. This is the axis here. In this case what you can get is that the true length of the axis is in this view and this view as well, and the top view of this axis is here in the second step. This length is the top view of the axis. This is oriented, this top view length is oriented at 30 degrees to VP. So that is what we are going to see, we are going to do here. So let us draw a line at 30 degrees. So line. Now this polar snap 30 settings you should do, 30 degree settings. Now we will draw a line first, horizontal line. Let us draw here so we have enough space. Okay. and 30-degree line. Okay, so we have drawn a line at 30 degrees to xy. Now we will reorient this top view, and the axis will be aligned with this 30-degree line. So that's what we are going to do now. For that, select and copy this view first. Okay, copy. This point is important. Base point is the end point of the axis, and place it here. Okay, one more time it is asking, so enter, hit enter. Now I will move this everything nearer to this view so that I have enough space. You may not need to move if you already have some space there. Now let us select this and rotate this so that the top view of the axis, that is this axis in this view, is aligned with this 30-degree line. For that, now we'll rotate it with this base point and align it with the 30-degree line. So that is done now. So we have got now the top view. In the second step, we have reoriented it. Now this axis view is making 30 degrees with XY or 30 degrees with VP. Okay, now take the projections here from this view. Take the projections from the second step front view. Point of intersection should be named, and then we will connect those points. Now we have got these points by taking the projectors, and we have named those points. And now let us see how to connect the points. Now for getting the front view, we are seeing it from this direction. So whatever is visible, that completely will be shown connected with object line. You can see that the base is completely visible. So this base edges should be connected with object lines. Polar tracking off, polar trap snap off, CD, D, CB, BA, AE, and ED. So this is completely connected with the object lines. And then from the top base, what is nearer, let us connect that This is nearer 5 1, 5 4, 5 4, and 5 1, and then 1 2, and then outline should be connected with object lines. Outline, you have D4, this is also visible, and then E5 is visible, then A1 is visible, and B2 is also visible. Okay, connected. This age we can delete, it's creating a new confusion. Okay, now whatever is remaining is this 2 3 and 3 4. Can we see that you are seeing here 2 3 and 3 4 are very far away, so those will be connected with hidden line. Those are not visible. 2 3, okay, I have not taken line, 2 line, 2 3 and 3 4. Similarly, C3 is connected with a hidden line C3. Okay, I have not connected it up to C here. Okay, done. Now what about the axis? From the centers of the two bases, that is mostly overlapped by hidden line here. Whatever is not covered by hidden line, that portion we can show as axis line, remaining part. Okay, I have done something else. By mistake I have converted that into center line. Now I will click somewhere else, and now I will select the center layer and a line tool, and this portion is still not covered, so this much only is there for a center line. The rest of the portion is getting covered because of this hidden line, so that is overlap. So this is how we have completed the front view in the third step, and this is the complete solution of this sum. So this is the complete solution, all the three steps connected. Let us move to this sum. Pentagonal prism, edge of base 40 mm and axis height 100 mm, has one of its corner in the HP with the axis inclined at 30 degrees to HP and VP both. Draw the projection. Almost similar to this previous sum. You can see that everything is same except this last sentence here. Now what is here in this sum 15? Top view of the axis inclined at 30 degrees to VP, and here axis inclined at 30 degrees to HP and VP both. Now this last is important here. VP, true length of the axis is inclined at 30 degrees to VP. So 30 degrees is the true angle of inclination of the axis with VP. That is important. So let us see the solution for this. So first step, we have taken axis perpendicular to xy, perpendicular to HP, and first step is drawn. Second step, we will tilt it so that axis making angle of 30 degrees with HP. So this is tilted, and axis making 30 degrees with HP. And now third step, you will see 3D view almost similar here in the third step, because there that difference in the inclination angle is not felt. There is no major difference in the apparent angle and the true angle here. So this third step, we will tilt this solid such that the axis is making angle of 30 degrees to VP. So here VP is here, so axis making angle of 30 degrees to XY line. So only the difference will be in the true angle. Let us see that this 30 degrees is the true angle now. So let us see the solution. See, this is the solution for the first step. We have kept it on XY with one of the corners on the right side with respect to the observer. So we are going to tilt this. So that axis makes angle of 30 degrees with HP. So this is the second step solution. Axis making angle of 30 degree with HP. And third step, now slight difference is there that we have to see. We have to tilt it so that now true angle 30 degrees is with the true length. Let us see that on AutoCAD. See, these are the two steps solution. Now third step, we will tilt the true length of the axis at 30 degrees. The true length of the axis is seen in this view as well as in this view. Okay, this is the true length of the axis here. So this length is inclined at 30 degrees. So let us do that. For that purpose, let us draw the line in the projection layer. Ortho is off now, and 30 polar snap is done. Now another line at 30 degrees to this. Length is not so important, angle is very important here because 30 degrees is required. So 30 degrees length we have drawn, 30 degree line we have drawn. Now what we do, we copy the true length of the axis, place it here. So this is the true length of the axis. Select this, copy, then the point of reference is this one, and then place it here over this. Done, and then enter, so it will come out. Now this length you have to mark here. So we will draw again a horizontal line, that is a locus line from this point on this side. Done. And now actually we are tilting the top view. Okay, so top view, the apparent length of the axis is there, this angle is different. Okay, this is making apparent angle, but they want that the true length of the axis making true angle with VP. So true length we have marked at 30 degrees, that is the true angle. Now for drawing this top view, we will find out the apparent angle. For that purpose, let us select this length. For that Let us draw some length over that. Use some different color. Let us say dimension and hatch. For a time being, construction work only. Later on we'll delete that. This is the apparent length or the elevation length. Now select this and move. Reference point, this one. Okay, let us align this. Done. Now we will turn it and make it to mark on this locus. So rotate. Done. Enter. Select this point. Okay, and now rotate. You have to take care that it is exactly touching the locus line. Done. So this is how now we have got the apparent angle of inclination. This is actual inclination of the top view of the axis, and that we have found out. If you want, you can measure these dimensions as well. So dimension and hatch is already there. So just give this angular dimension here. See, this is the true length of the axis, making true inclination with XY line. Okay. And now what is the apparent angle? We don't know, but we have marked that now. This is the concept used. This concept we have used from projection of lines. You can recall that. Now same angular dimensions between this apparent length of the axis or elevation length and the XY line. So approximately it is more. Always apparent angle is more than the true angle. So we have got the apparent angle. If they ask the question, you can measure this and give the answer that this is the apparent angle. But now they have not asked the angle. Instead, we have to reorient the top view at this apparent angle and then take the projections for the front view and complete the front view. So let us do that now. So we have reoriented this top view at the apparent angle and taken the projections from the second step front view. Point of intersections have been connected, seeing that the nearness of the edges to the observer is here, and accordingly this is the final step front view. Only the difference between previous sum and this sum is this angle. Here the true angle is given for the true length, whereas in the previous sum it was the top view of the axis making 30 degrees. So that is the only difference. So this is the solution for all the three steps. Let us move ahead. See this now. A hexagonal prism, edge of base 30 mm, axis height 75 mm, has its base edge inclined at 30 degrees to HP and in the VP. That is the difference here. Okay, it's a hexagonal prism. Okay, but now what is given here is that it's a base edge inclined at 30 degrees to HP. Okay, but the base edge is in the VP. So first step, we have to keep this on VP with the axis perpendicular to VP. Second step, we will interpret it further. Draw the projection if the rectangular side face containing that edge is inclined at 30 degrees to VP. So this is the data for this second step. So we will tilt it so that the rectangular face will make an angle of 30 degrees with VP. And the third step, the edge of that rectangular face making 30 degrees with HP. So let us see the solution. See the model first. So this is the first step. Since the edge of the base is in the VP, since given that edge of the base is in the VP, first step we have kept it on the VP with the axis perpendicular to VP. Second step, we have tilted it so that this rectangular face here, this rectangular face that is gone here, making 30 degrees with VP. VP is here. So that is done in the second step. So this is the second step. And third step, this edge which is there in the VP, this edge is making 30 degrees with HP. So we are going to redraw this such that this is making 30 degrees with HP. So let us see the model for that. So this is that model for this. You can see that 30 degrees for this edge which is there in the VP. So 30 degrees. That is redrawn at 30 degrees. You will see the solution. First step, we have kept it on VP. So this is the prism, hexagonal prism kept on VP, front view and the top view. Second step, we will tilt it, that is the top view is tilted so that this edge is making 30 degrees with XY, because that is a rectangular face. They said that it is making 30 degrees with VP. So this is taken care in this step. And third step, we will reorient this front view so that this edge DE is inclined at 30 degrees to XY, and then take the projections and complete the top view in the third step. So just see the solution here. It is along similar lines now. We will not solve it now. I have already solved it, and this is the solution. See now what we have done in the third step. We have reoriented this view. We have reoriented this complete view so that DE is inclined at 30 degrees. 30 degrees. This is 30 degrees. 30 degrees to XY. So this is reproduced here, and then taken the projections, and from the second step, top view, we have taken the horizontal projectors, and then we have seen it from this side to draw the top view. Observer is here, and whichever edges are nearer, those are connected by object lines, and the far away edges are connected with hidden lines, and that's how we have completed the top view for the third step. Read this pentagonal pyramid, edge of base 35 mm, axis height 70 mm is lying on one of its triangular faces in the VP. See that it's lying on triangular face in the VP. It is important. So first step data we have got that we have to keep the axis perpendicular to VP and the pentagonal pyramid resting on its base on VP. So that is the data for the first step. Second step, read further, draw the projections when its axis is inclined to HP at 45 degrees and apex is nearer to the observer. Axis is inclined at 45 degrees. This is the data for the third step. What is the data for the second step? Triangular faces. It's lying on triangular faces, triangular face in the VP. Okay, so this is important. So this is the data for the second step. And third step, we are going to reorient the second step front view, or rather top view, and then see that axis is inclined to HP at 45 degrees and apex is nearer to the observer. Let us see this. See, this is the first step. We have kept the pyramid on VP. Okay, first step. Second step, triangular face resting on VP. That is the data for the second step. We have tilted it so that this triangular face, the triangular face here, which is not seen here, that is on VP. This is the second step. Third step, axis makes an angle of 45 degrees with HP. Now axis making 45 degrees with HP, so we have reoriented it so that axis makes 45 degrees with HP and apex is nearer to the observer. This is also important. Apex is nearer to the observer. Apex is nearer to the observer. So let us see the solution now for this sum. This is the model. This is the first step. We have kept one of the base edges perpendicular to XY because the triangular face will lie on VP in the second step. So we have kept it on the right side, so it is easier to tilt it now. This is the first step solution. Then second step, we are tilting it. We are tilting this so that this lie on XY and the triangular face will lie on XY or VP. This is the second step. And third step is important, axis making angle of 45 degrees with HP. That is the true angle of the axis is given. So 45 degree line we will draw. We will plot the true length of the axis. In which view are we getting true length? Are we getting the true length here? No. Then we are getting the true length here. Okay, because here it is parallel to HP, so this is giving the true length of the axis. So take this length and mark it on this 45 degree line. Then draw the locus like this, and then take this apparent length. Apparent length is here. So this is the apparent length. Take this length and cut on this locus and you get the apparent angle. So this is the apparent angle. Reorient this front view, add the apparent angle. So this is drawn here, and then take the projections down, take the projections horizontally and connect the edges according to the visibility. Now you have to take care that apex is nearer to the observer. Observer is here, so apex is nearer to the observer. That is correct. Now accordingly, visibility wise, we do these connections and complete this top view of the third step. And this is the last one for this session. Write circular cone, diameter of base 40 mm, axis height 75 mm, is resting on a point of its base on HP. So this gives the data for the first step. It is resting on the point of the base on HP. So first step, we will keep the axis perpendicular to HP and the cone resting on its base on HP. First step. Second step, data is here, apex 70 mm above the HP. So we have to tilt it in such a way that the apex is 70 mm above XY. And the axis of the cone makes an angle of 45 degrees with the VP. This is the data for the third step. We will reorient the view so that axis makes 45 degree with VP and then complete the third view of the last step. So let us see the model first. So first step, we have kept the cone on HP. Second step, we have tilted it so that this apex, so that the apex is at 70 mm height. So we have tilted it on one of the point on the rim. So it is tilted on this point. and this apex distance from horizontal reference plane is 70 mm. So that is done in the second step. And third step, we have to reorient that axis making 45 degrees with VP. So this is reoriented so that the axis making 45 degree with VP. Now in this case it is XY line. So that is done now in the third step. Let us see the solution. First step, all right. Second step, we have to reproduce it in such a way that we will draw the locus at around 70 mm above XY. This locus line is drawn, and then we will take this distance and we'll keep this point here G and cut on the locus and reproduce this figure then. So that is the second step, front view. Then take the projections and take horizontal projections from the first step, top view. You get the points, see the visibility things accordingly, connect those points with object line and the hidden line, and complete the top view of the second step. And in the third step we have to reorient the top view of the second step such that axis making 45, it means that the true length of the axis, again we have to find out the apparent length using this concept. So the true length of the axis is here in this view. So mark this length at 45 degrees, mark this length at 45, get the locus, and then get this apparent length. This is the apparent length, and you can mark the apparent angle there and reorient this accordingly to that apparent angle. Take the projections and complete the front view of the last step. This is how all the sums are solved now. I hope everybody has got enough clarity about the projection of solids, orthographic projection of solids. Those sums involving 3 steps we have gradually dealt, and we have finished most of the variety of the sums. And hopefully if everything is clear, you would be able to solve any kind of sum involving 3 steps. All the best for your preparation. In case of doubt, we will have one doubt clearing session and clarify your doubts.